Hi, my name is Zach Anderson, and today I will be going over coding problem set 2.4, credit card payment recursive bisection search for minimal monthly payment. So similar to the other questions that we had for problem set 2, a lot of this information is the same, highlighting here that we need to know the balance is $5,000 and the annual interest rate is 18%. So if we scroll down here, we see that all we're doing in this problem is revising our bisection search solution, and we're using a recursive function instead. So if we head over to the code here, we have all of our variables declared up here, and most of them are the same. We did add the epsilon value here, and basically the point of the epsilon value is it's kind of like precision control, so it's the lowest that it can go without hitting 0, basically. So it just kind of helps the loop, and then it's like once the balance is within like a cent of 0 after the 12 months, then the algorithm is going to like consider that it's like cool, that's close enough to 0. This first block here highlighted is the block that uses a recursive function to calculate the balance after 12 months. So we are defining the recursive payment here, and we are passing these variables in here. So we have an if statement setting to if month equals 12, and then we're returning the balance. This is the base case, so the end of 12 months, and then we return the balance. So down here we have our similar calculations, calculating the unpaid balance that we have, and then updating said balance after we're adding the interest back in. And then this line right here is recursively calculating for the next month. So once again, we are passing in these arguments here, and then this is adding 1 to month. So hence with this 12, this will run 12 different times to go through the 12 months of the year. So this next big block is a recursive function to calculate the minimum monthly payment. So this was kind of the big idea. This is what we used the bisection search for in problem 3. So this is what we wanted to change up and make a recursive function. And we do that here. So here we're defining it, and then we're passing in all these arguments of the lower bound, upper bound, the OG balance, the monthly interest rate, and the epsilon. Here we define the minimum pay equation. So we use the math of upper bound and lower bound divided by 2. And this line right here is calculating what the balance is going to be after 12 months of payments. And as you can see, we pass in the same arguments here and then tie it to the balance variable. Similarly to what we did, this is adjusting the bounds. So it's basically if the balance is greater than 0, so if the balance remains positive, we want to increase the lower bound. And similarly down here, if the balance is negative, we're decreasing the upper bound. Once again, calling all the proper variables we need to make sure these bounds are adjusted properly. And then this final line down here, bringing back the minimum pay to basically start the recursive search for the minimum payment. So this is the final call to the recursive method for it to go, and then for everything to run as we need it to, and then tie our final value of this minimum pay. And then this is a rounding. This is just rounding the minimum pay variable. So whatever number it spits out, this will just help round it to 2 decimal places. And then finally, we have our print statement down here, which is what it is. It's simply just printing the final value of minimum pay with the heading of lowest payment. And finally, since we've now seen everything, we can head back up here, run this code, make sure everything gets connected properly, and then once that's all good to go, we can see that boom, and just so we can watch it, make sure, boom, 451.63, everything is good to go. Thank you.